All right, our first unit is going to be on radicals, and we're going to talk about what those are. Our goal is to be able to simplify radicals. All right, before we do so, we're going to talk about perfect squares, cubes, and fourths. So you're probably familiar with perfect squares and probably a few perfect cubes. So 9 is a perfect square. And the reason for that is because 3 squared is equal to 9. So if I take the square root of 9, I get 3. And again, that's because of this. So this is just kind of reversing back and forth. So you can think of all the perfect squares by basically just taking 1 squared, which perfect square would be 1. Okay, so then the next one, 2 squared, 4. Okay, so you could write up top here, this is 1 squared, 2 squared, 3, etc. So 3 squared is 9. Oops, I think I have the wrong purple there. And then 4 squared is 16. I guess we'll okay, and so I have, this would be 25, 6 squared is 36, 49, 64, 81, and then 10 squared is 100. By the same token, we could do the same thing with perfect cubes. So 1 to the third power is 1, so that's a perfect cube as well. So if I took the cube root of 3, I would get that. So, okay. Now, next I could do 2 cubed. 2 cubed is 8. 3 cubed, 3 times 3 times 3 is 27. 4 cubed is 64. 5 cubed is 125. 216. 343. You kind of get the picture here. 512, 729, and then you'd have 1,000. Perfect fourths work the same way. So 2 to the 4th is 16. 3 to the 4th is 81. 256. 625. 1296. 2,401. 4,096. And etc. Okay, so really this is 8 to the 4th power. So these are called perfect squares, perfect cubes, and perfect fourths. I'm going to put a list of these up through 15, so you can use that as a reference. You'll need that. Okay, so what the heck is a radical? So you've seen the square root symbol before. That's actually a radical. So a little more specifically, we can have different numbers here. So the nth root of a real number, a. So this a underneath the square root symbol, this square root symbol is not always a square root. So we call it, this is called a radical sign. Okay. The number underneath the radical, that a there, that is called a radicand. Okay. And then this number, this n right here, this is our index, okay? And I'm going to explain that here a little bit more. Okay. If there is not one written, so if you see this, notice there's no number here, then it is assumed that that's a 2. That's why we call it a square root. So then if it's not written, we know that that's actually a 2. That's a hidden 2. Okay? So you say, well, that doesn't quite make sense. Well, we just talked about, actually, I'm going to erase this. We just said, well, okay, so you might see the cube root of 27. Well, we just went and said, if we go back up here, notice 27 is a perfect cube. It's 3. So this means 3 to the third power is 27. So that means the cube root, not square root now, the cube root of 27 has to be 3 then. So that is what we mean by the index. So this would be equal to 3. Okay? That's how we use parts of radicals. All right. So if I said, what is the fourth root of 625, it would go up, let's come up here, 625 is 5. Okay, so this would be equal to 5. All right, so those are radicals, and we can have different indices there rather than just a square root. We can have the third root and a fourth root, etc. Okay, now a couple other things. You can have more than one root. You probably know this, maybe you don't. But the square root of 16, you know, is 4, right? And that is because 4 squared gives me 16. Well, you might not also remember that 4 squared, negative 4 squared, is also 16. Negative 4 times negative 4 is also 16. So really, this is really both positive 4 and negative 4. So we sometimes write plus or minus like that, meaning there's 2 answers there, plus 4 and negative 4. Same thing with the square root of 11, or 21. 121 is both positive and negative 11. Okay? So really, any square root should have 2 answers. And again, because you square something, you can get rid of that negative, so that makes it positive. So this is plus or minus 17. I don't know if you remember with fractions, really, square root of 4/25, you can break this apart as the square root of 4 over the square root of 25. So this is really, square root of 4 is 2, and square root of 25 is 5. Okay, so that's really plus or minus 2/5. Okay, so how about cube roots? Well, we already said the cube root of 8 is 2. This one doesn't work, though, with negatives, right? If we do negative 2 to the third power, do we get positive 8? We get negative 2 times negative 2 times negative 2. This is 4 times negative 2, which is negative 8. So notice that doesn't work here. So I only have one root. It's just positive 2. So the cube root of 8 is positive 2. And if you have an odd index, you'll only have one answer here. Okay, so the cube root of 343, if you go back and look at your list, you'll notice that this is 7. Okay? Now, I can get negatives here. Oh, okay, that was weird. I can get negatives. So we just said I can get the negative 2 times negative 2 times negative 2 was negative 8. Well, the cube root of negative 125, we know the cube root of 125 is 5. So what about this? Negative 5 times negative 5 times negative 5. This is 25 times negative 5 does give us negative 125. So this is negative 5. Now I only have one root here, not positive there. So this, if I have an odd index here, then I'll only have one root. And if that's negative this is also the only time you can have a negative underneath the radical is if the index is odd. That's an important point. Okay. Otherwise, we get something called an imaginary number, which we'll talk about later. Okay. So this would be equal to negative. The cube root of 1 is 1. Cube root of 27 is 3. So this would be equal to negative 1/3. Okay, and then here, again, now I've got an even index. So fourth root is 1, but it's also negative 1, so it's plus or minus 1. And 2,401, if you go back and look at your chart there, it's plus or minus 7. This is plus or minus 8. So then this would be plus or minus cube root of 81 is 3. And cube root of 16 is 2. Again, not square root, cube root. So be careful you don't put 9/4 there. Okay, so you notice a couple of things. If the index is even, and the radicand, meaning the number underneath, is positive, then you get real numbers. And how many roots do you have? 2. The positive version and the negative version. Okay, if your index is odd, like these, and the number underneath is positive, then it's also a real number, and that's positive. If it's odd, okay, and your number underneath is negative, like the cube root of negative 125 there, then we have a real number, and this is a negative number. Okay, now the ones that we haven't talked about is even. So let's say we have the square root of negative 16. So this is really even because it's really a 2, right? My index. This you cannot do. If you try to type this into your calculator, it won't work. So this is something called an imaginary number. We won't touch on that just yet, but if you have this, you can get a positive and negative version of that imaginary number. So these we're not quite there yet. Okay. All right. Next time we're going to talk a little bit about how we simplify radicals, and we'll go from there. See ya.